So in this platform, I want us to check our dynamics question from the question paper of April 2024. Let us consider what we were given here. That is the first part, 3.1. You were given, in this case, to name two changes. Okay, name two changes a force can produce on the motion of an object due to Newton's second law. What is it that we are going to have, or the change that is going to happen? So remember, we talk of the momentum. So we're going to have the first part, that is 3.1, the change of momentum. All right, so we're going to have the change of momentum, which is per time that we are given. So it is change of momentum per time. Unit is proportional to the applied force. All right, is proportional to the applied force. So that is what we can also consider. Also, we can consider the change takes place in direction of the working line of the force. So the change takes place in direction of the line of the force. So that is also what you need to consider on that other part, which is two changes that you can have. Also, you can talk of the acceleration, all right? The change that is going to happen in terms of the acceleration. So you can consider the acceleration of an object depends directly on the net force. So acceleration is directly to the net force. That one is going to be directly to the net force that you are given, and inversely to the mass. All right. So also that is another part to consider. Guys, just go through your Newton's second law by defining that, you know, the changes that are there. All right. 3.2, you were given a train with a mass of 300 megagrams. All right. So it has got 300 megagrams accelerated uniformly on a horizontal railway line. So this is just a horizontal surface that you're given, guys. So let's just take our information and try to have it this way. So that is 3.2. So we've got a horizontal part. So where we are given a train, which is an horizontal, it is being accelerated, meaning to say there is a change in speed that is going to happen in that case. But we're talking of what? Of a horizontal way. Then we have got the mass. Okay, let's consider that mass. The mass there is given as 300 megagrams, and we do understand that mega, it is simply times 10 to the exponent of 6. So that is 300 times 10 to the exponent of 6 grams. But we do understand the mass being taken in kilograms, and a kilogram is equal to 1,000 grams. So just divide this by 1,000, or by 1 times 10 to the exponent of 3, which represents 1,000. That is going to give us the mass in kilograms. So it was going to be 300,000 kilograms. So there we've got a mass of 300,000 kilograms from the megagram that we are given there. You can write it in a way that we do understand. So we have got the resistance against motion is 10 Newton per ton. The resistance against motion, as it is accelerating this side, there is a resistance against motion, which is the frictional force. So we are told that this frictional force is compared per ton, per each ton, 10 Newton per ton, 10 Newton per ton, per 1 ton, we have got 10 Newtons. So the question is, how many tons do we have? That is the question. 300,000 kilograms in a ton. We have got how many kilograms? That's 1,000 kilograms. So meaning to say, in 300,000 kilograms that we are going to have, how many tons do we have? Simply going to divide by 1,000. So if you divide this by 1,000, we are going to remain with the 300 tons. So in terms of the mass in tons, our mass is 300 tons, which is same as 300,000 kilograms. So there it is compared in terms of the ton. So that's why you must also have it in terms of the ton. So meaning to say, from this, our frictional force can actually be calculated as a 10 Newton times the mass per ton, which is 300. And that was going to give us something like 3,000. All right, so that's 3,000 Newton, which is our frictional force. So this is what we have there. Then we're given the tension of the tie bar is 50 kilonewton, which is the force that we are given. That is the tension. So meaning to say our force, which is the tension, is to be taken as 50 kilonewton, which is 50,000 Newton. So that is what we're given. So the question is, calculate the following. The force that will pull the train at constant speed. At this constant speed that we are given, what is going to be the force to pull? Meaning to say that is going to be our frictional force in this case, all right? So we have got the applied force, the frictional, so the one that is going to be opposing in the other way at constant speed, it is going to be taken at constant speed. So we have already answered these guys, those 3.21. So at constant speed, remember that at constant speed, our force, which is to the frictional force, we're not going to use this force, we use the frictional force. So meaning to say, if you're using the frictional force, we have already calculated our frictional force there. So remember that mass per ton, the force per ton that you're given there. Then the accelerating force. So the accelerating force, remember from the MA formula, mass times acceleration formula, it states that our FA are supposed to work with the substitution part. All right, so for that, let us consider. We are going to consider the sum of our forces equating to our MA. So there, like I said, we've got two things to consider: the force and this accelerating force. Together, it must be equivalent to the what? If we combine everything that we are having in this case, if you add these two, you add everything, you are supposed to obtain, in this case, right, this was supposed to be like this, guys. I missed out on my diagram here. All right, so this effect now, when I was just working out this thing, just affected me. So it's gonna be like this, guys. Our MA in this case is gonna be equal to the accelerating force, which is simply F minus the frictional force. So just like this. All right. So I just hope it is clear. I was actually working on another part, then also checking another part also. So this is going to be the difference. So as we need the part of our FA here, so meaning to say our FA must be F minus the frictional force in that case. So meaning to say we can consider the difference between the two. So that means our accelerating force is going to be 5,000. That was 50,000, 50 kilonewtons. So it's going to be 50,000 minus, remember, we calculated the frictional force, which is at what? 300 Newton. So there we're going to have our difference, which is the difference of what? 47,000 Newton. All right. So having the frictional force, we can also calculate the acceleration. Remember, this is taken from what? From MA, and our MA is equal to this. Remember, that is our MA, which is equal to FA, and we calculated our FA here. So 3.23. It means our MA is equal to what? 47,000, which is our FA. So that is equal to 47,000. Given the mass in kilograms, we've got the mass of 300,000 kilograms there. So that is, we're just going to divide by the mass to obtain acceleration. So that's 47,000 divided to the mass, which is, in this case, it was 300,000 kilograms. All right, so that is going to give us an acceleration, which was going to be 0.157 meters per square second. Remember, this is what? Acceleration. So considering acceleration, you must work also with the units meters per square second. All right, so I just hope it's clear from our formulas just got affected. You see, when you're working with these networks, guys, sometimes it just affects along, then everything just tends to be upside down. But let's just hope it is clear then. Then on the other part, I want you to see there we are given a truck with a mass of 3 tons breaks. Take note, it breaks. Okay, the mass of 3 tons. This is a statement on this one, so it was supposed to be a comma here. Then brakes are released. All right. And it rolls down an incline. All right, I talked about this, that if you are given an incline like this and the brakes are being applied, it means we have got a starting point here. Let's say this is where our truck is. As it is at this point, it is initially at 0 meters per second. So take note, guys, when the brakes are being released, now it starts to go down this way. When these brakes are being applied, now it's going to go down. So we have got the mass of 3 tons, which is 3,000 kilograms. Remember, a ton is 1,000 kilograms. Down an incline of 25 degrees to the horizontal plane. The tractive resistance is 1,200. As it is going down, it is going to be opposed. This other way, it is going to be opposed by what? 1,200 Newton. Calculate the speed of the truck after 45 meters down as it is going down when it is going to cover 45 meters down the incline. We do not know, is it going to be at the end, but after covering 45 meters, what we are very sure is the initial part. As we are starting at this point, that will start at 0. We do not know about the initial point there. Like we have it at 0 because it was just like a standstill. Then you apply the brakes, now it starts to move, meaning to say there's a movement, there's a velocity. So that's why we have to consider that speed. But when it is going to cover up to what? 45 meters. So we need to calculate V, which we do not know. All right, so let's see what we have in this case. We need to manipulate our formulas in favor of what we can. This velocity is of the linear motion, meaning to say we have to think of those formulas. V is equal to U plus AT. Remember those formulas. V squared is equal to U squared plus 2AS. V is equal to U. All right, we got this one. We're going to have also the S, which is equal to UT plus half AT squared. All right, so so many formulas that we can think of. So as we can see, there is need of time, acceleration. Even if you were to work with this one, we need acceleration, okay? Because already we know that U is there, it's a 0. If you are to use this one, you need time, still acceleration. So there's something about acceleration time there. So let's start with the acceleration. Where can you obtain the acceleration? Definitely, if we have got the accelerating force, just like previously, if you have accelerating force, you can calculate an acceleration. So in this case, our accelerating force is simply going to be the opposite of what we have, which is, in this case, we are going this side, which is we're going to consider our parallel component in this case. Okay, so as we consider this accelerating, this frictional force, which is in this case our parallel component, opposed with the frictional force on this side. Sorry for that. So this opposed by the frictional force and the accelerating, because we are also trying to accelerate. So meaning to say that will be the difference between these two. So just like what we saw previously, it was the total force minus the frictional. So in this case, you consider the force on the other side, which is the parallel component in that case, opposed to the frictional force, opposed to the frictional force. So in this case, we're going to have the parallel component. Remember, from this, going to have that perpendicular and also parallel from the mass times the gravitational acceleration times the sine of the angle. So this is from our mg sine of theta, which is the weight times the sine of theta, but the weight is mg. So that is 30,000, 3,000 there. Sorry for that. That is 3,000 times the gravitational acceleration sine of 25 degrees. So this whole part is going to subtract the frictional force, which is 1,200. All right. So this was going to give us something like 11,224,977 Newton. So having the mass, remember we need to calculate acceleration because we've got the mass and the accelerating force, and we saw that FA is equal to MA. So acceleration is just going to be divided by the mass. So that's FA over the mass. So acceleration is going to be FA. All right, so let's take our FA here as it is. Then we divide to the mass that we are given. That mass is 3,000 kilograms. So we're going to divide to 3,000. That will give us the acceleration. Actually, there we've got now the acceleration of 3742 meters per square second. So you had to play around to calculate the acceleration. So in this case, let us try and see. It does not mean you have to calculate a lot of things there to have this final velocity. Like after this, you have got acceleration, which is in this case 3,742 meters per square second. Initially, you started at 0 meters per second, and you must cover a distance of 45 meters. What is the velocity within this? We can calculate this velocity, guys. We can calculate this. So also the formula sheet, guys, there is no formula like this of UTS is equal to UT plus half AT squared, not V. There is no formula for V like this. V is equal to. So like I was saying, even from other videos, that our department, guys, they need to work with these signs and for in terms of revising it, guys. Like, you see, when you are revising this alone, you get like, what are they trying to do here? A lot of errors. So in this case, you need V, so you can use that formula. Like I said, you cannot use this as V there. No, this is S. Take also your formula sheet. Understand your formula sheet. So if you are to use this formula, you're going to calculate first the time from this formula. Then you use it here to calculate your final value. But there is a formula there which we also do need to understand. Most times we work this formula as this: V squared minus U squared over 2A is equal to S. Remember this formula, guys. It can be used, this formula. Remember this. Most times you work it like this. It can be written this way. So from that formula, V squared is equal to U squared plus 2AS. We can find our final velocity. Introduce the square root. So V is equal to the square root of U. Remember, that's a 0 there. So that's 0 squared plus 2 times A, our acceleration, 3,742 times S, which is 45 meters like this. So that was going to give us our V, which was going to be 18,352 in meters per second. All right. So in terms of the calculation there, do verify when you are using your memo there. Do not just take the answer as it is. Okay, this is no, because these guys, like, they do make a lot of mistakes. But anyways, that is what you're supposed to have done in this question, working with the incline. Just try to work out with the formulas of linear motion and also consider the part that you're given of the forces. You can calculate your accelerating force, which can help you to calculate the acceleration that you need in these linear motion formulas that you need there. After that, you can apply any suitable formula. Like I said, if you're to use this formula, you're going to calculate the time. After calculating the time, then you use this one. V is equal to U plus 80, this one. So using this one, remember that at the initial part, we are going to have, let me just save it here so that we do not have confusion, because there, if you work with your formula sheet, with your memo, guys, you're just going to have a lot of mistakes there. All right. So using this, we can calculate the time. S is equal to UT plus half AT squared. So remember, U is 0 there. So meaning say there's nothing there. So S is going to be, remember S, we have it, but it was 45 meters. So you're going to have 45 meters is equal to half times the acceleration of 3,742 times t squared. So just cross multiply by these two. So it's 45 times 2. Then you divide by 3,742. This is equal to t squared. Introduce the square root since you need the value of t there. So your time was going to be 4,904 seconds. If you're using this, So having time, guys, we have got acceleration, time, initial. We know that initially it's at 0. So you can use that formula. V is equal to U plus 80. Knowing that V, I mean the U there is a 0. Remember, that's the same concept that you used here, that V is a 0 there. So that is going to be 0 plus 80. The acceleration that you calculated, remember, you had your acceleration 3,742. That is if you are using this way. 3,742 times the time that we calculated here, which is 4,904. So still we're going to obtain our velocity, which is 18,351 in meters per second. So guys, that's another way that you could have opted to use. Still, you're going to have the same thing. So that's why I'm saying do revise your formulas, understand them, because if you just take as it is there, you'll be using wrong things because of things that are not revised. So we just need to work more on that. So that's what we had on this platform. We are going to check more questions to come. But for now, that's it. Till we meet again.